be the number of $50 bills. So now we can make two equations here. One of them is we know that if we count the number of bills, they're 15. So one equation is a real simple x plus y equal 15. Usually in these type problems, each number is a different equation, okay? Now, we know that that's just telling me the number of bills. But we have another number, and it's the total value. So for the total value, we can describe that. If you were to take your money and you counted it, it would add up to $390, right? Well, you'd have some $20 bills, and you'd have some $50 bills. You have X $20 bills, so let's say I had two $20 bills. I could say 20 times 2 is $40 in bills, but I don't know how many there were. I don't know that there were two. So I say, but there were X of them, okay? So I could say, well, 20 times X would give me the total value of the $20 bills. So this is the value of just the 20s. And then I need the value of the 50s represented. Okay? Well, however, there were Y of those. We don't know if there were 2, 3, 4, but we do know there were Y of them, and however many they are, if I multiply by 50, that's how much they were worth, just the $50 bills. Okay, so now I've got these two equations, and I can solve them pretty easily. Here's what I would do in this instance. I would do substitution. And the reason I would choose substitution is that I have this single X and Y over here. And so maybe I solve for Y, okay? So if I solve for Y, if I have X plus Y equal 15, if I want to get Y by itself, I can just subtract X from both sides. And I get Y equal 15 minus X. And now if you remember what we do next is we take that and we go to the other equation and we put it in the other equation that we didn't use, okay? So I've got this equation right here. So 20X plus 50Y, but instead of Y, since Y is equal to 15 minus X, I'll just say, well, I'm going to take Y out and put 15 minus X in and substitute that for its value. Okay? So now if I want to find out the X, which is going to be how many 20s I've got, all I got to do is solve this equation. It's only got one variable, so it's very doable. So we have 20X plus, now 50 times 15 would be 750, and then remember you got to also distribute to the X. That would be minus 50X is equal to 390. Okay, so now 20X minus 50X would be negative 30X. So I have negative 30X plus 750 is equal to 390. Now if I want to get X by itself, I could subtract 750 from both sides. Okay, let's see what that would be. 0, 15 minus 9 is 6, 6 minus 3 is 3. Let me see, is that right? 0. Yeah, so if you subtract that, would be a negative 360. This would cancel out, and I'd have negative 30X is equal to negative 360. And if I want to get X by itself, all I need to do is divide both sides by negative 30. And I get, oh, well, what is X? X is negative 360 divided by negative 30, and negative divided by negative is a positive, and 30 goes into 360. That's the same thing as, like if I cross my zeros off, 3 goes into 36 12 times. Oh, so I have 12 20s. I'll put my answers over here, okay? Now I need to know how many. I'll put I have 12 20s and blank 50s. Okay? Now, if I want to know what Y is, all I got to do is go, hey, I got Y all by itself right here, and where I underlined it in green. Y is just 15 minus X, but now I know what X is. It's 12. So 15 minus 12 is 3. Oh, I have 3 50s. 12 plus 3 is 15, and if you think about it, let's check that answer. If I had 12 20s, 12 times 20 would be 240. And if I had 3 50s, 3 times 50 is 150. Does that add up to 390? Yes, it does. So I know I got the answer right. Okay, we'll look at number 3 now. I'm going to work the problems. That way, if you have trouble with word problems, you've got somewhere to kind of go to help you through it. But just see if you can go back and do them after watching the video. See how far you can get, and just keep trying them until you can get the whole problem worked. Find the measures of the angles of an isosceles triangle. Well, let me draw it. I'm going to say that this side and this side are the same, and that means this angle and this angle are the same. Find the measure of an isosceles triangle if the measure of the vertex angle, now remember the vertex angle is going to be this angle up here. The measure of that vertex angle is 40 degrees less than, so minus 40 from something, less than what? The sum of the measures of the base angles. Let's say the base angles, since they're equal, we'll call them x. If it's 40 degrees less than the sum of the base angles, if I add the two base angles together, x plus x is 2x. So I could represent the vertex angle as 2x minus 40. And they want to know what all the measures are. All right, well, the thing I know about triangles, if you remember from geometry, is that all the angles add up to 180. So we could say, well, x plus 2x minus 40 is equal to 180. And this one won't even take that long to solve because you think about it, you got an x, another x is 2x, and two more x's make 4x. 4x minus 40 is 180. Okay, if I want to solve for the variable x, I can add 40 to both sides to make it cancel out over here and go away on the left. So now I have 4x is equal to 220. And if I want to get x by itself, I could divide both sides by 4. And I get x equals 55. Let's see. Yeah, that's 55. All right, so x is 55. So that means the angles, remember we're supposed to use complete sentences when we do word problems. The angles are 55 degrees for one. Another one's 50, because you got two equal base angles that are x, 55 degrees. And now what about the vertex angle? For the vertex angle, it was 2x minus 40. But we know that x is 55, so we'll stick that in. It's up there in green at the top of the triangle. 2 times 55 is 110. No, 111. Let me do this. Sorry, I'm working without a calculator. My brain's tired. I got it right. It was 110. Okay. 110 minus 40 should be 70 if I didn't mess anything up. So let's see. Yep, that should be it. So then 70 degrees. And so that's what we could do to list the angles. All right, so the next one was number 7. With tailwind, a helicopter traveled 300 miles, which is distance, right? And his time that he traveled it in is 1 hour, 40 minutes. Okay? And so now, what is his rate is what we want to know. Well, we know that when we see distance and time, that somehow we're going to be using distance equal rate times time. That little formula, rate, some people say distance equals speed times time, but a rate is a speed, so it doesn't matter what you write there. All right, so he's got a certain rate that he's going. I'm going to wait to fill that in for a minute because I kind of know how these problems tend to run, so I'm going to wait. The return trip against the same wind. Okay, so here he's got some wind, okay, going on, and the wind's helping him go faster. If it's a tailwind, it's pushing him. So he's going to get there faster. But when he's coming back, the return trip against the same wind took 20 minutes longer. All right, so he went the same distance. But his time, if you add 20 minutes to 1 hour and 40 minutes, that's going to be 2 hours. You know what? I see that I got mixed hours and minutes. I'm just going to go ahead and make this 100. I'm just going to make things in minutes to work with it. It's 120 minutes. Up here, 1 hour and 40 minutes would be 100 minutes. 60 minutes in 1 hour, and then add 40. Okay? Now, it says find the wind speed and also the airspeed of the helicopter. All right, here's what we got to think. Let's let R be the speed of the helicopter without the wind. So I'm going to put speed of heli without wind. And let's let W be the wind speed, because there's two separate speeds here. Now, if you think about it, his rate would normally just be his speed, R, except that there's some more helping him. The wind's pushing him, making him go faster, so I need to add the wind speed in up here, because it's at his tail. But when he's coming back, his rate is going to be the same. Let's see, he's going the same speed, basically, but the wind's working against him. So we would normally go the same speed, except we got to subtract out the wind because that's reducing how fast he's going, okay? And what they want us to do is find both of these speeds. All right. Now, what do we know? We know that the distance is the same. Distance, this is, let me write in green here, going and returning. The distance is the same going and returning. So distance, I'll just going equal distance returning. Now, how can I describe the distances? That's what's equal, okay? Well, going, if you think about it, if his distance is his rate times his time, I'll do this in blue up here. His distance up here is his rate, which is r plus w, times the time, 100. Now, I could put the 100 after it. I'm going to put it before it just because I like the way that looks. So distance is his rate times his time, 100 minutes. So I could describe the distance. I know it's 300, but I could describe it as 100 times r plus w. And then over here, distance returning, and let's do that in a purple color. Over here is return distance is still 300, but what is it? It's his rate times his time. I'm going to do what I did above. The time I'm going to write first because it's a whole number. And then his rate is r minus w. Okay, so I could do this. This is one way I could do it. But you know what? I kind of, that's one way I could represent it, and we could do it that way. But I could also do it this way. Maybe it would be easier. Let me draw another line because we're just trying to think all the different ways maybe we could kind of approach this. So sometimes we brainstorm, and that's what I'm doing right now. Let me pick a dark green here, okay? So now here's another way I could look at it. If distance is rate times time up here, we know the distance up on the top is, and I'll write it in blue just so I can show you where I'm getting this information. It's 300. Maybe I want to have that as an equation. 100 times r plus w is equal to 300. That's the first one. Now the second, when he's returning, his distance of 300 is equal to that rate times time, which we'd already set up as 120 times r minus w. Now I'm going to choose to do it the second way. I could work on it the first way, but I'm just going to still end up with two variables. That's what my thought was. We could try that, but I think the easier way to do this problem would be to say, well, going, we've got his distance, his rate, and his time, and coming, we got his distance, his rate, and his time, and we described them all with the same variable. Okay, you could probably solve this at this point. I'm going to have to go really fast, and I doubt I'm going to be able to finish it on this video. But I would have, if you simplified this one over here, it would be 100R plus 100W is 300. And over here I'd have 120R minus 120W equal 300, just distributing. And what's going to have to happen here, I'm going to have to get rid of a variable. So let's see. I could say this, maybe the smallest thing that both of these would divide into would be 1,200. I'm going to get rid of my W's, okay? So if I multiply the top one by 12, I'd get the equation 1,200R plus 1,200W equal 300. And down here, if I want to get rid of the W's and I want to get 1,200 out in front, I like that I already have this subtraction sign here, but if I multiplied everything by 10, I'd get 1,200R minus 1,200W equal, that would actually be 3,000, and I forgot to multiply 30W times 12. 30 times 12 would be 360W. And you could finish solving this. I'm just going to do the setup for you. Those would cancel out. You'd get 2,400R equal 3,360W, and you could solve that.